Because the importance of the forest will only increase, we need to find ways not only to manage it properly, but to engineer it as well. This is where biotechnology comes into play. Imagine if we could substantially accelerate the growth of trees, or grow them in arid environments, reforesting whole areas on which hardly anything at all grows today. Or if we could improve all the properties of wood that make it so useful in the construction industry. The starting point for doing any of these things is to understand the genome and how it programs the biology of the organism. In a major undertaking, Yrjö Helariutta and his team have recently analyzed the full genome of the birch. The genome, plus a panel of relevant genetic variants, make it possible to identify the genes that control the way the tree grows.
Jotta me voidaan ymmärtää, että se on todella geeneissä se virhe, eikä jossakin muuten joku kasvi on vähän vaurioitunut, niin meidän täytyy pystyä seuraamaan sukupolvesta toiseen tätä prosessia ja sillä tavalla pystyy näkemään, että se periytyy se geenivirhe.
The genes which control plant development and specify the formation of the vascular system are basically the same in all plants. So, by using the model plant species Arabidopsis, equivalent to the fruit fly for plant biologists, we are able to speed up discovery. We can translate knowledge obtained in a plant like Arabidopsis, which grows to maturity in a matter of weeks, to much slower growing species like trees that take years to reach maturity.
If we think about trees, so this would take, I would basically ask my daughter to wrap up these experiments.
Long after your death.
Right. But in Arabidopsis, the generation time is rather than tens of years, it's like a couple of months.
Even though it's only a tiny little weedy plant of a few centimeters in height, it nevertheless is making the same constituents that go into making wood in trees.
If we would really understand the wood formation process in depth, we might, in Arabidopsis and trees, we might be able to create Arabidopsis, which is actually looking like a tree.
Okay, that's an interesting concept.
Kasveissa liturassa me ymmärretään jo aika paljon, miten geenit määrittelee tätä oksakulmaa esimerkiksi. Ja on näytetty, että myös puussa oksakulmat määritellään hyvin samalla tavalla. Me voidaan käyttää tätä lituruohoa jossain määrin mallina myös puun tämmöisen arkkitehtuurin ymmärtämiseen.
But then you can use that knowledge in the future to engineer the properties of the tree plant.
Me voidaan periaatteessa saada puut kasvamaan nopeammin, jolloin me saadaan ne tehokkaammiksi hiilinieluiksi tai sitten me saadaan enemmän biomassaa. Toinen vaihtoehto on jalostaa puun laatua. Esimerkiksi niin, että me halutaan vahvistaa sen soluseinän rakennetta, siitä tulee parempi esimerkiksi hiilinielu.
In the future, genetics and gene editing will offer us ways to customize the properties of wood and even the rate at which trees grow. The more we learn about trees, the more we can use and modify their properties for human benefit. But it's their role as a defense against climate change that remains our most urgent priority.